Good morning, everyone. Thanks for coming to our talk. So we'll be speaking today about a few impactful bugs that we found that were submitted to our program, which led to adding additional capabilities and refining our controls. And we'll also talk about how to upgrade your program if you're already running a bug bounty program. I'm Vinay. I manage the application security team at Snapchat, and I've been working on product security and pen testing for about 15 years now.
And I'm Murali. I help with the bug bounty program along with the AppSec team, and I also have like around 15 years of information security experience.
So today we'll talk a little bit about our bug bounty program at Snapchat, how we run it, some statistics, and then we'll go over 3 specific issues that were submitted, which were really impactful for us to add additional controls. We'll talk about investigation details, we'll talk about root cause analysis, and then any learnings that you can take back. And throughout the talk, I'll try to keep it, provide resources and actionable items so that you can take it back and actually put that within your own program. So Snapchat operates at a large scale. We have about 400 million daily active users. And on our platform, we serve about 850 million users in all. We build hardware and software that enables self-expression. And for those of you who use Snapchat, you know that you can send messages, you can send snaps, pictures, a lot of different multimedia content. We also have rich feature set. So we have snap lenses with which you can make yourself look silly if that's your thing. And that is actually an app store where any developer can create a lens and then submit it, and then that gets executed within a JavaScript engine. We also have snap maps where you can share live locations. We also have Spotlight where anyone can create their own content and share it with the public. But unlike other social media out there, we don't have the concept of public posts or feed. Everything is private by default. And the reason I say this is all of these different features and interactions lead to some interesting bugs, and that's why we attract a large number of bug hunters. And one of the most important things is we serve a large audience. Our majority of our audience is 13 to 30, so security and privacy is sort of utmost importance for Snapchat. Quick plug, we are hiring across our InfoSec program. So we have positions open in application security engineering, corporate security engineering, and infrastructure. Check out our careers website, and if you're interested in writing software to make applications and infrastructure secure, please reach out. So some quick disclaimers. This is what worked for us, and depending on your bug bounty program, your own vertical, your experience might vary. All the findings that we talk about today have been disclosed on the HackerOne platform, and if you want to look at additional details, you can go find them there. And please note that bug bounties are not a replacement for SDLC or pen testing. You always have to shift left and do other security controls as usual. A quick introduction on our program. We launched in 2015. We are quite a high volume program, and that's because anyone can download Snapchat and start hacking or finding bugs and submit it. So because of this, we sometimes get on a year close to 1,000 issues. And the way we scale it is sometimes we use internal and external resources to do the triage. And we eliminate a large number of positives so that our internal team can then go do deep dive and root cause analysis on the actual findings. We also have a pretty high tier payout. And so for our tier A, which is our main Snapchat application, we pay up to $35K for a critical bug. And for the lower tier, other assets that we have, we pay out up to $5,000. We have slowly ramped up our program and added additional scope over the past 10 years. And thanks for hearing my marketing for our program, so please participate. That's the long story short. And as of 2024, we paid out over $1 million US. I'll hand it over to Murali to talk about some issues.
Yeah, let's get into the technical aspects here. So the first issue, we are going to call it stranger events. The reason why we named this is because it involves a third-party library called FS Events, and I'll get into more details about what it is and what the vulnerability was in the next slides. So let's start with the basics. What is FS Events? It is a file monitoring software. It's a third-party library that's mostly used by Node.js developers, and typically it is used for like running tests and monitoring your file system and things like that. But the way it gets into a developer's machine is kind of interesting. So for a Node.js developer, they use something called NodeMon for monitoring, and this has a dependency on another library called Chokidar, which has a dependency on FS Events. So you can see like it's a transitive dependency for almost all Node.js developers. And it is a fairly popular library because it sees over 19 million downloads weekly. So what happened was last year in April, there was an advisory created on GitHub that talked about a security vulnerability in FS Events, which can lead to RC. The issue here was that there was no CVE associated with this, and because of that, like it was not caught by any of our open source, vulnerability scanners, because they mostly look at CVE databases for finding open source vulnerabilities. So if you look at the attack scenario for this, like what happens is during the build process of FS Events in the older version, it used to download a binary package as part of the build and then start executing that. So this behavior has changed in the later versions, but essentially there is like a pre-built binary that was downloaded as part of this package build. This might sound similar to last year's XCutils, but unlike that, this didn't get much media coverage. So essentially, like when a developer builds a Node.js application, it gets all the packages from NPM, and one of that happens to be FS Events. In this vulnerability, what happened was a security researcher had taken over the S3 bucket and started serving a different binary than what was expected.
In general, it's already a little shady that a NPM package is downloading a binary from an S3 bucket. So it has a lot of red flags, but let's keep going and seeing how it impacts.
So essentially, when we got a bug bounty report saying that we have a vulnerable FS Events package, and there is proof that it executed in our environment, we started a quick security incident to track this issue, and our detection response team was involved, and they did a complete payload analysis and found that this only affected macOS because that's where the execution happened. And also, the binary that was downloaded was not intentionally malicious. It was more of a proof of concept binary created by a security researcher to collect basic information about the execution environment. Things like the present working directory, the machine name, things like that. And there was no malicious impact observed as part of running this package. So let's tie it all together. So what really happened last year, there was a GitHub advisory. They fixed the issue, and apparently the developer deleted this S3 bucket. 3 months later is when we started seeing this HackerOne bug bounty submission. It's interesting to know that this is because of AWS behavior. So if you delete a bucket on AWS, it takes up to 3 months for that namespace to be released, and anyone can claim it. We quickly spun up a security incident in our own internal security response, And we did a complete payload analysis to find what the behavior is and also understand where we are affected. So the researcher found like 2 or 3 instances, but we did a complete scan of all our services for this dependency and also relied on our endpoint detection software for scanning our developer laptops to see if a vulnerable version was downloaded. Ultimately, we also worked with the HackerOne community and found that the researcher was submitting the same type of issue on multiple HackerOne programs, and basically finding the same issue which would be fixed if you can fix the root cause. So by working with AWS, what we did was we told them about this issue that's affecting multiple companies, and basically they were able to add this FS events bucket namespace into a reserved list which cannot be claimed by anyone in the future. Looking into incident response, we were working with our open source software scanners to identify all instances of this vulnerability and patching them as appropriate. We also relied on a service inventory of all the services and the developer owners for them to quickly reach out to them and issue a patch. Additionally, we depended on endpoint detection capabilities and detection response to identify the impact of this vulnerability and to fix them.
So to summarize, what are the capabilities that you need to think about in your own environment, right? So one, you want to patch and fix any open source vulnerability that has, any package that has an open source vulnerability. So for that, you need a robust dependency scanner so that you can identify all instances. And the second thing is you want to do this as quickly as possible, which is mean time to respond. And to do that, you need to have a service inventory so that you can route this findings to the service owners. So that's something that we went back and sort of fixed in our process, because we did have a service inventory, but a lot of time that gets abandoned, people leave, people move. So even if you're a company of starting to get into the size of 250 plus, then you want to maintain a robust service inventory and service owners. So those are sort of the takeaways from this incident. Now let's look at another fun one.
All right, so this poster is probably showing its age because it shows a DVD release over here. Anyway, we call this the cell phone booth, and I'll get into more details. So before we talk about the actual vulnerability, I would like to make sure everyone understands some basics about Android applications. All Android applications contain something called as a manifest XML. It's basically an XML that contains definitions of what the application does. Things like, does it need access to the camera? Does it need access to the file system or SMS, things like that. And this also defines how the application behaves. Every screen on your Android application is called as an activity. Think of it as your profile screen or your login screen. They interact with the application using intents and intent filters. So essentially, when you log in, you enter the username and password. This is sent to the application, and it understands how to handle this username and password. And tying it all together, we also have something called as deep links, which are definitions within the manifest that define how another application can call into your application and launch a functionality.
So if you have received any link sometimes and you click it and it opens within an app, that's actually a deep link. And it's important because that's the only way two different apps can communicate with each other. And they're defined within a URI protocol, which we'll show in the next slide. Well, before that, you'll see the vulnerability.
Yeah, so let's look at the initial report that we got from the bug bounty program. So it took us a while to really understand this because they just submitted this video. So right now, the research was showing that they have the latest version of the app, and they're not using an older version. Then, oh, sorry. And once they show that it's the latest version over here, the next thing that they do is launch the web browser on the phone and then click on a link. Immediately, this launches the Snapchat application, and it starts a video call in the background. So this was a vulnerability that they submitted. It took us a while to understand what was the issue here. But essentially, if you understand what's going on, there are certain necessary conditions for this attack. The first condition is that you can only affect a victim who is connected to you by a friend relation. And if so, what you can then do is start a conversation on Snapchat web client, capture the conversation ID associated with that, and then craft a specially crafted Snapchat protocol URL, and then send it to the victim in some way. You can send it as an email or put it on a forum post or something like that. And then if the victim clicks on that link, immediately Snapchat sees it as a deep link and starts accepting the asset by the default behavior. So in this case, the victim would see, the Snapchat application would see the calling media, and it's a video call, and it's for this particular conversation, and all parties in the conversation will start receiving that video call.
So if you look at the deep link down there, it says starts with Snapchat, right? So that says that this link should be opened by the Snapchat app. And then it says it starts a new chat, which basically saying start a new conversation. And then it says the calling media type is video, and the conversation ID is what you captured before. And then it's saying it's not a group call, it's one-to-one, right? So it's basically, this is what you end up embedding in and getting the victim to click on, which is sort of the typical social engineering act, but the only thing here is that it initiates a full video call without actually accepting or you actually providing that intent that you want to start this call. So that's sort of the root cause here.
If you look at the timeline, we received an issue initially from HackerOne platform. We kicked off something called as a privacy incident for this case because it was more of a user's privacy that was being violated. And we also, in parallel, fixed the issue, but also worked with our detection and response team to collect telemetry about any usage of this in the wild. We issued the fix to the Android Play Store. It was important in this scenario to have monitoring in place because, as you might be aware, not everyone updates their applications on their phone regularly. So even if you issue a patch, it may not be applied immediately. So we kept monitoring for any malicious activity that's going on while working with the fix.
So the way we did that was to look for that URI intent. So if there was an activity that was initiated through the Snapchat URI, which is not very common because a lot of folks are directly, when you start a video call through the Snapchat mobile app, it's completely different than from a web. So this is sort of like using both the features together, and that's kind of like odd. That was actually not an intended feature, but the researcher used it. So looking for that anomaly was quite easy. But when we looked at it, it was mostly the same, us trying to repro the issue or the researcher trying to just provide us a proof of concept. And it was only found on Android.
Yeah. A few things that helped us during this incident was having a definition for a privacy bug bar. I'm sure all of you have a security bug bar, but you should also consider having a privacy bug bar for handling these cases. Some factors that determine the severity of a bug for a privacy bug bar that we found useful are listed here. The first one is data sensitivity. What we mean by that is in Snapchat, you can have user-generated content, you can have aggregated user content, or you can have user metadata that describes a user. So all of these have different sensitivity levels. Depending on what is compromised, you might bump up or down the severity. The second factor would be the exposure scale. We often do A/B testing where a new feature is rolled out to a section of the population. So depending on how many users are potentially affected, is it 0.1% versus 10% or 50%, the severity of the issue can be changed. Another factor that's probably unique to our scenario is the existence of a friend graph. Having an issue limited to only your friends is lower severity than affecting everyone because there's an implicit trust involved there. And it also prevents you from randomly targeting another user who is not your friend. And lastly, like in the security bug bar, the likelihood of exploitation, like how easy is it for someone to exploit this issue is also considered.
So essentially go back and see if you need a privacy bug bar and work with your legal and privacy teams. And that'll sort of help you prioritize a bug when you have an incident which sort of borders the security and privacy phase. Okay. So let's look at some of the capabilities that you want to take back. Having a privacy bug bar, that'll be solid. But more than that, think about when you add new features. So we introduced Snapchat Web in 2022. And then when we introduced that specific feature, the conversation ID sort of got exposed, which otherwise was not being exposed through the mobile application. So that's when the researcher went back and used the Snapchat Web protocol and then identified that you can introduce this, you can add this conversation ID and then initiate a call, right? So a feature that was intended only for mobile was moved to web, which behaved slightly differently. So anytime you add a new feature which is completely tangential, you might want to look at how it interacts with the existing features. And so the way we fixed this was a user dialog will come up when you want to initiate a phone call to ask, are you sure you want to start this call? Or like, just say, actually call, just the call button.
Awesome. The third issue is probably very important nowadays with all the attention to AI and ML. Jupyter notebooks are used extensively by machine learning and data scientists. So let's look into this one. So a quick intro, what is Jupyter? It is a document format where you embed visualizations and data into your document. And it essentially runs Python code to calculate some values or render some visualizations. It has 3 hosting models. One is local, where it's on your machine. Private hosting, where your IT team or your infrastructure team will be hosting that. Or it can be cloud hosted with all the major cloud providers.
I call it a Excel, which is on the browser with a database in the backend, which is used to then calculate some stuff and show you on the web browser. So that's how I look at it.
For this vulnerability, it's important to understand how Jupyter executions happen. So you, as a user, would be interacting with the web browser, but all the Python commands are executing in an IPython kernel in the backend. This becomes important in the later stage.
The IPython kernel is actually installed on your desktop or the client machine where you're actually executing Jupyter Notebook.
If you look at it, it's Python code execution. And the developers of Jupyter had considered the risks associated with it and came up with a fairly good mental model while designing the security controls. The essential thing to think about is, did the user initiate an action that resulted in code being executed? And that was the tenet that they were going by. So essentially, any untrusted HTML or JavaScript is not executed. Any JavaScript or HTML in a markdown is not executed. And any command is not executed until the user clicks on the, the play button that's shown on the UI. However, one thing to note here is output generated from an execution is considered trusted because the user initiated the initial execution. So coming back to the bug bounty report, we got a blind XSS report that said that the researcher was injecting an XSS polyglot in multiple places on Snapchat, and essentially after 2 weeks, he got a call back from an execution of an XSS. And they were not sure where the execution happened, but they reported like a low finding that there is a blind XSS happening somewhere in our environment. A quick side note, an XSS polyglot is a string that's specially crafted that will execute in multiple contexts, whether it's HTML or attribute or JavaScript, without changing the string. So it's very useful for a security researcher to keep using the same string and inject it in multiple contexts.
So in this case, they were putting it in the user agent, which we were then capturing in some of our logs, which you will then see how it ended up into a Jupyter notebook.
So the attack scenario, when we analyzed, we found that the researcher was injecting the string in a user agent as a user agent string, and it just went into a BigQuery database in the backend. Later on, a data scientist on our team was checking some reports and executing, downloading this data, and then running a report on Jupyter Notebooks, and that's when the actual XSS was triggered. It's very important to understand an XSS is not just an XSS in the context of Jupyter Notebooks. Because of the existence of the IPython kernel, the XSS or JavaScript code can essentially now interact with this kernel in the backend and issue Python commands to it. And this is why it becomes super critical whenever an XSS is associated with a Jupyter Notebook. So it's demo time, keeping fingers crossed.
So essentially, we want to show how to break out of the browser context and actually execute code on your, on the client machine. Let's see if we are successful.
Oh, yeah. Oh, my God. Yes. OK. So in this demo, like essentially,
Make it bigger. That'll make it bigger. Just go to view, just make it slightly bigger.
OK.
Yep.
So here I have an input string, and this is the intended behavior. It's just reflected back, whatever the input string is. So in this demo application, I can change the input string to an XSS string that's shown here, and you get a typical XSS alert box. But also, because of the existence of this IPython kernel, you can create a specially crafted XSS string that interacts with the IPython kernel, and if it's successful, yeah, it launches calc in the background, or any command that you want. Okay. All right, so looking at the timeline, the researcher injected an XSS polyglot, waited 2 weeks to receive a callback. We immediately started a security incident for this, identified which report was affected, also did a variant analysis of all IPYNB files that are in the environment to see if other reports have a similar issue that might be affected. We issued a fix. We contacted the researcher saying that, OK, we have identified the issue and fixed it. We also bumped up the bounty for this case because they came in as a low severity, but we actually figured out it's much more impactful. The researcher waited 2 more weeks just to make sure things are fine, and we were able to close this report.
Awesome. So in summary, go look at within your own environments if you're using Jupyter notebooks and make sure they're contextually encoded. And don't go by the researchers' severe rating because they might not have the full context of your own environment. A lot of times we rush to trying to keep it as the severity as low as possible, but actually doing a root cause analysis and taking a step back and seeing if there can be privilege escalation or if there could be chaining, just like how we were able to chain here, that's important. And finally, patch your Jupyter versions. That's not something that folks tend to generally focus their attention on because the assumption is, hey, this is all in a trusted browser context. It's not super critical. But as we showed, you can break out of that context under specific conditions to then execute code on the client machine. Preferably, you want to use hosted versions over on the cloud. Most of the cloud providers provide that. That'll help offload the updating and execution onto the cloud servers. Awesome. So given that you've seen all the different issues that can be possible, I'm sure you're all excited to go launch your own bug bounty. But yeah, so if you want to launch a bug bounty in your own companies, you want to think about having a mental model or framework and some sort of a checklist to go launch it, right? Because you want to have capabilities to be able to triage the bug. You want to be able to handle a volume. And you also want to provide the researcher a good experience. So for that, you want to start somewhere. And for folks who don't want to go and immediately contact a vendor, or if you're not sure how to go about, here are some resources and also the way you want to go about thinking to launch a bug bounty program. So the first and most important thing is try to keep in your mind that you're going to launch private. A lot of folks think of a bug bounty program as a pen test as a service, and that, in my opinion, is a disaster because researchers will go after the low-hanging fruits, and there will be a huge volume. And if you're not ready to handle that, it could be a bad start. Also, any bug bounty program when you launch, you will get unknown issues that you would not expect. Like there will be scope that they'll identify or instances that you might have not thought about. So all of this will come into picture when you launch public. So launching in private for about 6 months to a year, and then going public is probably the best route. Also think about your scope and budget, and start small and slowly increase the scope and the budget over a period of time. All of this will lead to a better positive experience, and researchers will come back to your program. So one of the resources out there is sectemplates.com. Thanks, shout out to Robert Auger. He's put together a list together to go about how to launch a program, how to think about the reporting and bug bounty policy, safe harbor policy, all of that. Going through this will give you a good idea about what it actually takes to launch a program. For folks who are already launched a program and want to think about more nuanced issues like the scope, budget, handling disputes with researchers, all of these sort of like a little bit more nuanced issues. A good place to come and join us is Bug Bounty Community of Interest. It's a Slack channel, and also we have monthly meetings where we go over grievances or we talk about like what issues we are facing. So this is a good resource for folks who already have a bug bounty program. Awesome. So for folks who now have a program and want to level up, here is some tips and tricks that you can take back. I'll hand it over to Murali for the first tip.
So the first tip is ensure you have the right capabilities. Essentially, like having a risk-based SLA for all vulnerabilities is important. This helps in prioritization and timing and fixes. Service inventory or identifying of the responsible owners of a particular service is really important because you often have to deal with multiple teams, and finding the right team quickly is important in incident response. Reachability analysis will help you with prioritization. For example, an issue might affect multiple services, but some of them may not be end-user facing or not internet exposed. So you can probably prioritize the ones that are end-user facing first before fixing the remaining issues. And you also have to worry about completeness. The bug bounty researcher has given you one instance of the problem, but you might have similar instances in other applications that they are not aware of, but you have the source code, you have the insights, inside knowledge of figuring this out on your own. And like any program, you are not working in a silo. You have to work with other people in the company, developers, privacy, security, or incident response. And yeah, think of all the cross communication that you can enhance. And think of these capabilities as constantly evolving. It's not set in stone. So as you deal with a security incident, you would identify certain deficiencies in your program. For example, your service inventory is not complete and you miss something. It could also be, you did not have scanning capabilities for a particular type of issue. So think of these deficiencies and constantly improve your program to make it better.
So for those of you who have a program for about 6 months to a year, you already have some metrics. So go look at these metrics, right? Like especially how many submissions have happened for a particular asset. By asset, I mean a domain or a particular website or a particular product or service that you might have. This gives a good insight into what the researchers are going after. Are some of your assets not being paid attention to? And if they're not, then you can sort of nudge the researchers to those other assets which are being ignored, right? Submissions by vulnerability, I've highlighted that because that's a crucial metric because that will inform your investments for your next year's program. A lot of times we go after doing campaigns and systemic fixes by looking at a vulnerability type. So for example, if they're constantly going over like XSS or NIDOR, then we know that we have to go and create a framework or create a path for developers so that they don't get the same issue. The response efficiency is crucial because most of the time the researchers are looking at how much time they're investing to get $1, right? At the end of the day, that's what the bug bounty hunter cares about, is if I submit an issue, how long does it get for me to get paid out? And keeping this low helps them incentivize to come back to your program. And from your own internal metric standpoint, your MTTR depends on how much time did it take to close from submission. That'll help you inform what kind of capabilities do you need to add to keep reducing that, right? So over a period of time, you want to generally reduce these metrics. False positive and out of scope submissions are interesting because that will define whether you want to further refine your policy and you want to refine your scope, because if you're constantly seeing the same kind of issues that are submitted which are not in your scope or policy, there's triage fatigue, right? So to eliminate this, you want to have a tight scope and also list out these are the issues that we already know about, or like these are actually not issues for us. Finally, the rewards, again, to help scope, to budget, and to forecast, you want to know how much bounty you're paying for an asset and vulnerability type, so that then you can then forecast this in case you've not invested in those areas yet.
Yeah, like in programs, seeking feedback is important. This is some of the feedback that we receive from the actual participants or security researchers. So for them, the key metric is time to bounty. Make it as easy as possible for them to get rewards or to actually start submitting issues. And one of them is to just give, like if you have a premium subscription, give out premium subscriptions for researchers, or have clear documentation that help them to get to where they want to test. Another important aspect is to have candid feedback regarding bounty payouts and the impact decisions that are made. And this reasoning will help them understand we treat them with respect. And last but not least, think of the human behind the hacker and treat them as people.
So the last thing is don't stagnate, don't let your program stagnate. A lot of them set it and forget it and see there is a constant number of issues coming and then it looks fine. But every quarter or every 6 months, go back and sort of like, gamify your bug bounty program. So some of the things that we do are we do CTFs, we put time restraint challenges in place so that folks can come back and say like, hey, for these 2 weeks, you will get additional bonus for this asset, which is not being paid attention to, so we'll just raise the bounty for a particular asset so that gets tested well. In the past, we have done live hacking events. It's quite interesting when you bring a group of folks together. Sometimes they end up like finding 2 or 3 low issues, end up chaining it and finding a critical bug. So live hacking events are fun, and then finally gamify your program, right? Like constantly just publish a bug of the month on your platform. Anyway, a lot of researchers want it to be disclosed, so calling it bug of the month is super easy and gives them an additional incentive. We also have leaderboards, so we publish leaderboards. We have small swag. And then also provide bonuses, right? Like if your reward is, if a researcher submits a very clear report or really finds an interesting issue, just provide a bonus. Sometimes just that $100 bonus and is sort of like makes them super happy, even though the reward itself was like $4,000. So it's interesting. Humans react to incentives, so make use of that and gamify it for them. Awesome. So for those of you who do bug bounty hunting on the side, we have a private CTF that's starting next week. It's focused on our authentication stack. Just one of the ways to keep leveling up our program. So if anyone wants to participate and has a HackerOne handle, please come and say hi after the talk, and we'll add you to the CTF. For anyone who's interested in knowing more of the capabilities around detection and monitoring, and also the incident response capabilities that we added to our own applications, take a look at this book that was written by some of our coworkers. We talk a little bit about like what capabilities you can add to lower that MTTR, especially in a production environment. It goes a little bit more forward than just theoretical. It's actually applied to the production environment that we run. Well, thank you so much for coming to our talk. Let us know if you have any questions.